here you are also able to design your system on secondary alloy in order to get the sustainability advantage over other processes.
Curious question. From which region does your customer come from?
Asia.
Uh-huh. Have you done trials with European customers?
Yes, we have as well.
Did the European customer succeed or fail?
It failed.
Did the Asian customer succeed or fail?
And they succeeded.
What was the difference between the two projects? Hello, welcome back to the Gigacasting podcast. Today's episode, we are still on the theme about our dairy industry and what's happening, but we're going to shed some light in the tunnel. So to help us out with that and to point at some business opportunities, we have Dr. Per Jansson together with us today. So welcome, Dr. Jansson.
Thank you very much.
Normally, we actually ask people to introduce themselves, but I give it a try and then you fill in, okay? I'm guessing that you're 54 years old, the owner and founder of Opportunities Rheocasting, a company dealing with and developing equipment for semi-solid casting, basically Opportunities Rheocasting. I think you're an honorable doctor in Jönköping, probably because you helped them to get a big pile of grants over the years. And you have been working in the foundry industry since you can walk.
Yeah, pretty much. Yeah, I think you got most of it right, I would say, yes.
And you live in the metropolitan area of Skillingaryd, a town with 4,211 inhabitants.
Something like that, yes.
And it's your third appearance on the Gigacasting podcast.
We learn. So, before talking about all these things that one can accomplish in the die casting industry, what is your view of the industry in Europe and globally? And what do you think about die casting industry and the future?
Let's say like this, that the industry is going to most likely change in the coming years, depending a little bit on what you see in other fields. I mean, die casting is a process that is made for high volumes, so we need to apply it in commodities which require high volumes. And then it's natural that you turn yourself into the business of making cars, because that is a high volume industry. So high pressure die casting is very dependent in these type of industries. And automotive have been, I would say, the big market where foundries can sell their capacities to. But we see now big changes in the automotive industry in the form of that we are changing the drivetrain from going from ICE engines into electrical drivetrains, which affect the number of shots needed in one car, which will affect the suppliers of high-pressure die castings. And there will most likely become overcapacity in the die casting field.
Isn't it already?
Yeah, we see that is ongoing, especially, I would say, in Europe, where we see this happen first, but I think it will follow in other markets as well, so to say. So the big challenge for the high-pressure die casting community is to apply this technology to more applications, I would say. That is the biggest challenge the high-pressure die casting community have to do. And the problem is that the high-pressure die casting community, they are doers today, if I say like that. I mean, they don't really have any huge staff of business development or big staff in technical engineering when it comes to where to apply the technology, because that has been made by the customers to the foundries so far. And that is a circumstance that makes it even more difficult for the high-pressure die casting community to handle this.
What you're saying, they're lacking the tools of dealing with the situation.
I would say they don't have that organization, so they can handle this.
Yeah, I think especially with that changeover now, that you lose the article numbers that you require on the portals. For 20, 25 years, there was no need to do any business development and marketing because there was not enough die casting machines to fill the demand coming from our automotive customers via the portals. But now it's changing, and suddenly you never developed that skill, but now you need it. And probably also that skill is also needed to bringing the next generation into the foundry world.
Yeah, and you need different tools to adapt to this market. Simply as
Exactly.
that.
What tools are you thinking about?
Now I talk usually about the foundries that we can see in Europe. They are usually family owned, perhaps have between, well, let's say up to 20 die casting machines and so on. And there's a lot of money invested, perhaps already over generations and so on. So they need tools. First of all, how to find new business to gap fill the lack of the shots from automotive. And then they also need small adaptations so that the equipments they have can actually solve that problems the new applications need, if I say like that.
And I guess you're going to suggest one of these adaptations.
Yeah, well, that's natural. Since I myself come from a family-owned foundry and have seen what the Rheocasting can do to what you produce and how many more opportunities that feeds, I think it's strange that not we can have more people to see this. But again, I'm a little bit colored. I'm in this, of course.
Yeah, but if Rheocasting is that great, why is not everybody running it? What is your take on that question?
We have two statements. First of all, this is the way we have always done it. That is what people say as soon as something else comes up. That could be very dangerous to say like that. And then, as you said, nobody's doing it in that way, then it can't work. And I think there lies a lot of this in this. There's simply not enough experience so far. And the biggest reason why it has not taken off, I would say, is that the decision lies not in the foundry. They can't really affect this at all. Because the king in this, that is the guy who owns the drawing. They tell what they want to have made, so to say. And the foundry has very little or no influence in changing this. So if there's not a demand for it, then it will never be a supply.
So it starts with the car maker.
It starts with the car maker. It starts with the guy who owns the drawing.
The product owner.
Yes.
But is it like this all over the globe, or how are you doing in different markets? If you take your pick, go around the globe and give us your short overview of the different regions on this planet.
I would say in general, this goes in all markets, especially when it comes to automotive. Then, of course, there can be different tolerances and different incitements in people to act in different markets. Here in Europe, 100% it's from the drawing owner. We have rules in Europe. We like to make up rules and we like to follow them. So changing that here is very, very difficult. So here, in order to get Rheocasting going, we need to affect the guy who owns the drawing and explain to them the benefits they get from designing their castings for Rheocasting.
So Rheocasting is low in Europe.
I think the markets that attracts the technology fastest, I would say, is Asia and North America. I would say it's then we have certain different segments of the market that might be more positive to adapt the technology here in Europe, I would say. But overall, I would say the interest is bigger in Asia and North America than it is in Europe.
I think we need to make the world map a little bit more details. Here comes some questions. How is India doing?
Yeah, India is an interesting market. Here we see big movements in Rheocasting because India has a great two-wheel industry. And I think that the two-wheelers in India need or like to enhance their qualities. And also lightweighting is, of course, of interest for this type of industry. So I think the resistance of new technology is lower in a market like this.
And you have sold a bunch of machines in India.
Yeah, we have sold a few to India, yes.
Okay. Moving next one, Japan. How is Japan? It's a small island if you look at the other countries around it.
Well, Japan is a small island, might be, but it has quite a large industry when it comes to automotive. I think Japan, if I look at the Rheocasting incentives in Japan, it's very positive for us. They have come quite far today, and we see more and more applications that is going to be tested with Rheocasting. I think that it would not be unlikely if we see one of the Japanese OEMs to be the first to put Rheocasting in very high volumes for cars.
Interesting. But if that is happening in Japan, then it's very, very easy to jump into the next country, the country of copying and the mass production, China. How is China doing for you?
We see China, but I would say that is things that is brought over, developed here in Europe. I would say that is what they are starting first in China. And I think in China we probably would need to have good examples for Foundry to see, so they understand that it is a market behind this.
So what you're saying is that PowerPoint is useless in China, competition is the tool.
Definitely more than ever in China, because they have a slightly different way of developing parts in China as well compared to here.
But you have a couple of customers in China, right?
Yeah, we have.
And they're doing fine.
Yeah, they're doing fine so far.
From small to big ones.
Mm. And in different applications as well, and different market segments.
So someone made a bed in China, so now it's
ready there. I mean, we have just recently also made an agreement with a big material supplier that brings the supply of the Rheocasting alloys, especially if we look on thermal applications where we need to have high thermal conductivity in these. So that is in place also to help foundries to be able to get the materials. The name is PSW Group.
So, America. How is America doing?
North America also shows a great interest, especially, I mean, we have had one of our first major customers in North America from Canada that has been one of the pioneers in Rheocasting, and they have been running now for several years structural castings on secondary alloys, which we now see activities in North America, more and more customers that shows interest in this type of castings as well.
Would you say America is hotter than Europe?
I would say, I think we have more projects ongoing in America than we do in Europe.
So according to you, if I summarize, what you're saying is that Japan, number 1, India, number 2, China, number 3, US, number 4 on North America, and then number 5, on the 5th place, last place, Europe, when it comes to the implementation of Rheocasting.
Yeah, but we also have projects in Korea, so we can't forget about Korea.
Yeah, that's true.
Korea is also a very interesting market. I would say they are big in automotive, but they are also big in consumer electronics. They are big also in telecom. So I think Korea is a very interesting market as well for us.
Yeah. So to summarize the market a bit, when we see it, Rheocasting has arrived in several markets around the globe. Europe is lacking in that, and they're also lacking in the talent in business development. So you can say, oh, they're on last place. But when you turn it around and say, hey, if you want to really start, you have the best chance to get started in Europe, as the competition is the less.
Yeah, you could turn it around if you are a positive
if you
person.
want to see the bright side, and that should be that podcast episode about the light at the end of the tunnel. So there is a way out. And why not start in that continent where you have the least competition? And when you consider it in hyper-shot die casting, you have the most fierce competition.
And we are also making activities trying to lower the threshold to get into the semi-solid market, meaning that we have done quite some interesting findings lately on the eutectic alloys, meaning that to enter the semi-solid industry without needing to change the specification on the drawing.
Which alloys are you speaking about?
we talk about the 2 to 6 typical type of alloy, 46,000 as we say here in Europe, in order to get acquainted into the technology. And doing this, we have also seen benefits of that you can actually cut costs quite radical. I mean, you will save tools. Again, that is the most likely the product owner's end. But again, we know for Foundry business that we are starting to do a lot of processes that we never get paid of. I mean, we need to clean and deburr and do all this. And if we can delay that, that means directly we save money in the Foundry. We have shown that you can basically use a 40% small locking force die casting machine. And we all know that the buyers, they have already have a market price for 1,000 ton and a different price for a 1,600 ton machine, for instance. And the gap here is interesting because that can mean that you can make a part in a smaller die casting machine in order to increase your margin, or you can go for a business for a larger machine with your smaller machine.
Or you can free up the capacity on the large machines, because it's easier to get a new quote for high pressure die casting on larger machines and then fill your smaller, fully depreciated small machines with another 10, 15 years of lifetime and high margin products.
Yeah, exactly. It's a way of increasing your margin.
And also, these are products that you already have in your product portfolio. Nothing new to learn, no new customers, the same product, but with a lot less headaches.
Yeah, same product, same tool, same alloy, no change basically. And I mean, we also have partners here in this part of the world in Europe that knows the technology where people can get help, like Casting Campus, for instance, that can assist in getting people up and running very, very fast. So I hope that these new findings is something that the Foundry society can attract these guys.
Interesting. And you're still on the specification. So in theory, you don't need to say anything to anybody. Just collect the saving.
Basically, yes.
Same alloy, same tool, same after processing, same everything, but lesser tool wear, lesser porosity problems, smaller die casting machine, and you're good to go.
Sounds too good to be true, right?
Yeah.
But we have proven it in several projects.
Yeah. That's typical. Anyway, if one would look for parts also with low thresholds, easy to go into, what would be your second suggestion if you want to move into Rheocasting?
Well, with Rheocasting, you also, it's like a Swiss Army knife, right? Because then you also get the opportunity to make parts that is made in other casting processes, like gravity casting or low pressure die casting, because usually here we already use the alloys that has a lower silicon level, and I guess that's the problem, you know, if you reduce the silicon level, you are reducing a bit the castability, and but these castings usually already specified in these alloys.
So no change of alloy.
No change of alloy for the customer. It is the same alloy, it's just a different process that has a higher productivity. So this ought to be a win-win, because you should get more business to the high pressure die casting foundry, and you should be able to give an attractive offer to the buyer.
And you're not competing with your friends in the high pressure die casting industry because you're stealing the work from a permanent mold or low pressure caster.
It's new opportunities for the high pressure die casting foundries.
Yeah. But why going to Rheo instead of permanent mold in the first place?
I can fill in that. It's because when you go in for high volumes in die casting or sand casting or low pressure die casting, you have a certain capacity, the cycle time is quite long. And if you want to have a higher output, you need to buy a lot of machines to get that capacity. And the highest efficiency you can get in casting is with a high pressure die casting machine. And putting the same part on a high pressure die casting machine gives you an amazing unfair advantage over your die casting competition, and something no other high pressure die casting foundry can touch.
Yeah, exactly. And another benefit we have seen in projects like this is that since gravity casting is a slow solidifying process, you get quite coarse grain sizes. And in order to get the good properties in the casting, you have to apply usually solution heat treatment like T6 and so on. What happens then is that you get a very strong part, of course. But in certain cases with Rheocasting, which has a much faster solidification, it's good enough sometimes with only to apply heat aging, because that gives good enough mechanical properties.
And heat aging is T5?
T5, yes, which means that you get a much simpler heat treatment process and still good enough mechanical properties.
Must be much cheaper. You don't burn your parts up to 590 degrees for hours and hours and all that.
Exactly.
Also, when you talk about the carbon footprint, having such a long heat treatment cycle adds quite a lot to the carbon footprint.
Yeah, and sometimes you can even also suggest that you go from primary alloys into secondary alloys, and in this way also reduce the CO2 footprint. So we haven't really seen any downsides with Rheocasting in these applications.
One thing that's growing, I'm always interested when you look at cars. Everybody's talking about cars if they're born in the 70s like me. But if you start to look at mass transportation as a system, I saw some Rheocasted parts for charging stations, for example. So you see more and more add-on products. And one add-on that you never talk about because it's not visible is the server halls for self-driving cars and 5G. Are you working with 5G anything, and can you shed some light on this?
Yeah, we are into these applications as well. And I mean, here we also see is what we call the thermal segment. I mean, as soon as we add some electronics, and people like to have the electronics to be efficient, and they add effect into this, and then we get heat losses. So we have to remove heat. And by introducing Rheocasting, you're able to use different types of alloys, which you can't do in liquid casting because you don't then have the castability. And then these ways you can increase the material properties, such as thermal conductivity, but also due to the process nature of filling and so on, you get much less defects inside your casting, which allows, for instance, for laser welding, for instance, and things like that. So here is a bunch of other products where we can compete with, for instance, extruded, machined solutions, but you do it in casting.
And you see this as a growing market?
Yeah, I would say that this is going to grow quite dramatically, because we don't just need to talk about cars, we can talk about AI as well. That's everything should be AI today and so on. And these server halls will pop out like mushrooms from the earth, I would say, in the future. So
you already see it already that these server halls are deployed rack by rack. Everything is water cooled, because now when you look at the chips, they're a few centimeters times a few centimeters rectangle and push somewhere between 400 and a kilowatt of power through, and you have to get it away. So air cooling is no longer an option. Now everybody goes for water cooling, and then you have something like 8 to 10 GPUs times these 600 watts of heat plus 2 CPUs with a 500 watt power budget. And that's just one rack with 8 U, and there are 42 U's. So imagine what output, so you can heat cities with that energy coming through.
People are developing systems for heat recovery, basically.
Yeah.
yeah.
But what alloy are you using in the field of thermal management or thermal conductivity?
And there is one alloy called Rheocool, which has a ALSI 3 type of alloy, where we can have thermal conductivities up to 190 watts per meter Kelvin.
And where do I buy it?
That you can buy all around the globe. We already have sources here in Europe, here in Sweden we have Stena Aluminum, and in North America there's a company called Trialco, and then, as I mentioned earlier, in Asia we have this PSW group where you also can buy it. So
you don't need to play around and try to do it yourself. It's a off-the-shelf product.
yes.
Yeah. how high fins can you make with this alloy in a big heatsink?
Yeah, we have done over 100 millimeter. I think the highest is 120 with 1 millimeter thickness at the top. So you can make fairly complex geometries with this alloy. So I mean, that's no longer a limiting factor. The material is there, the technology is there. Now we just need the people with the fantasy to design the parts.
But you have a few, right? There are like 2 or 3 telecom companies already using Comtech Rheocasting.
Yeah, we have a few here from Sweden that is doing that, some multinationals. And we have also been with some US companies where we have applied this and so on. So there's nothing new, and there are several years of experience in doing this. So low copper content alloy as well, so we don't need to talk about corrosion issues and things like that. That's already taken care of. When it comes to thermal, I think this is a market segment where Rheocasting supersedes conventional high-pressure die casting.
I'm a little bit interested in one other thing. I heard a rumor in the market that Comtech Rheocasting is pretty big on leak-tight parts, and especially around the carbon dioxide. We even spoke about it in this podcast before. What is your take on the combination of Rheocasting and carbon dioxide air conditioning systems?
We have conducted a few projects like here, and since Rheocasting has a much more laminar flow, we can push out the trapped gas in a very good way. Due to the laminar flow, we have much less microporosities from the filling, and due to this, the final part have big difficulties in forming leak paths, meaning that when you talk about these systems, Rheocasting is the process to go forward. Another thing I think that should be an advantage with this is because if you look at the compressor systems for the driving compartment, so to say, in a car today, that they are usually today based on traditional high-pressure die casting. So if casting is not working and we are changing to CO2 systems, that means that the buyer then need to change process. He's introducing a new technology. You have to change the process to make it. He probably then need to change the supplier because they have different supplier than the high-pressure die casters. That means that is a huge problem for the car maker or the buyer of this. But if they go for Rheocasting, that means that they just need to push in an equipment in the existing supply chain to have a different metal preparation, and then they are ready to go with the same supplier, with the same output that they are used to. And at least on a paper, it seems to be a very simple solution for a very big problem.
But you have customers in this already, right?
Yes, we do.
Yes. With very thick NDA, so we leave it by that, I guess.
Yeah.
But to size the market here, I mean, how many parts is it in every system per car?
A compressor, I think, is typically 3 parts. And I don't know how many cars it's made. If fully built out in all cars in the world, I think it's around 250 million parts every year. Then.
That's a big pile of parts.
Yeah, that's a few.
You can fill several foundries with that.
Yeah.
Interesting. But then I guess you can use the same technology for other leak-tight parts like pump housings and refrigerators, heat pumps, whatever.
Anywhere where you have leak requirements, I would say that Rheocasting is a great process. And also, here again, instead of looking into others, here you are also able to design your system on secondary alloy in order to get the sustainability advantage over other processes.
Curious question. From which region does your customer come from?
Asia.
Uh-huh. Have you done trials with European customers?
Yes, we have as well.
Did the European customer succeed or fail?
It failed.
Did the Asian customer succeed or fail?
And they succeeded.
What was the difference between the two projects?
I would say that in Asia, they are more in-house. They have a bigger understanding of all the processes required, and especially the casting process, because they take control of the casting process and also of the part design. Here in Europe, it's more of a design house, and they outsource all the processes, so they have difficulties understanding the challenges with the process, meaning that they can't really take in that knowledge when they design the part.
So in Asia, they do DFC, Design for Casting.
Yeah, we can say.
Oh, invented a new management term here. So happy.
Yeah, that sounds handy. But I think one thing that we have to cover is that we have gone through the applications and have great prospects there to find new business. Another thing is that it all comes down to the cost. We had in several podcasts that cost pressure is rising up. So adding a new machine sounds like it will cost more money to produce the parts. So can you shine a light on how the Rheocasting process helps you with cost saving and increasing your margin at the same time?
You have to look what you're competing with. I mean, we can always use a smaller die casting machine, and the gap on the hourly rate between these two sizes of die casting machine will easily cover for the investment in a slurry maker. But then again, of course, we are there. People don't take my word for it. They want to see it themselves, so to say. So the way of doing it, I mean, there are several areas where people can come and probably get the trial casting of their own component to see this and to learn from their own instead of listening to others. Then they can test it and get hardware to compare. We can offer it from our facility here in Sweden, but I know there are places elsewhere where they also, depending on what size of machine is needed, so say what type of component. So people can just contact us, and then we'll help them with the right partner to get that tested.
And then they know.
Yeah, of course. I mean, you can see if for instance, if they cast a part today in a big machine, let's say a 1600-ton machine, and they have all the data from that, and if we can fit the tool in our 600-ton machine, we probably cast it for them as well, and then they can see the difference of the part on a 600-ton and a 1600-ton, and then they can judge themselves whether they think it will be cheaper to produce the part on a 600-ton.
Or if they want us to talk with the customer.
Yeah, we are actually doing things like that today, and we have done several projects on that, and then we haven't even brought in the benefits of actually changing the alloy. And I fully understand the people's reluctance in changing alloys and so on, how foundries are built up when it comes to the metal handling systems they have today and so on, that might be not the positive thing to hear, that you should change an alloy and so on. But
if you need it to survive, maybe it's another light. Huh?
It's also something where you can differentiate yourself on the market by offering something else that not everybody else has on the market.
Exactly.
But we have to speak a little bit about the naked lady in our industry. The only thing that attracts media to actually lift from the chair and actually go out there, and that is the Gigacastings. What is your take on Gigacastings, and how is Comtech positioned within the Gigacasting development and industry?
First of all, we have to say that as Foundry men, that we think that Gigacastings is a fantastic thing, because that brings the spotlight on the process again, and it becomes a little bit more sexy perhaps, and can attract talent to the industry. So that I'm all for. I think that's fantastic. When it comes to Gigacastings, there are parts that carry load, so to say, which means that properties like elongation and things like that, not just because it carries load, but they need to assemble it or connect it with other parts as well, like SPR and things like that requires then different type of properties of the material compared to perhaps a traditional casting. And what I have learned from that is that the traditional alloys that has been used in structural castings, ALSI10, MNMG, typically previously used in this, which needs heat treatment in order to get the ductility needed, so to say. But with these very large structures, heat treatment processes become a problem because then you need to straighten the part. And perhaps in certain cases it bends so much that it's not possible to bring it back to its original geometry. That means that people are searching more natural ductility. And the simplest way to go is to remove silicone. The problem by removing silicone is that you lose castability. You don't lose castability in semi-solid casting. You enhance the castability. So that's a perfect part for semi-solid casting, I would say, because then you can naturally reduce the silicone in order to get a more natural ductile material and increase the castability compared to casting in a liquid state. So for me, large structures with long flow lengths and things like that need ductile material, the only way forward is semi-solid casting.
Do you think that's the only reason? I mean, if you look at the production cost of a gigacasting and reliability of the machinery, don't you think that 100 degrees cooler melt and a smaller die casting machine also plays a role? Not to mention the exchange of shot sleeves and plunger tips and all that that you have to deal with in the production. I mean, after all, it's supposed to deliver directly into the assembly line.
Yeah, but this comes as number two. When they understand how to make it, then this will come afterwards.
It sounds that you know a lot about this. Where are you positioned when it comes to customers and sales?
But we also have incitments and projects going on in Asia, and can't really talk so much about that here.
Only in Asia?
No, but we talk with people in North America and Europe as well. But the people that have come the furthest is Asia, of course.
Again,
yeah.
So we see that you need quite a bit of knowledge or know-how to get started. Is the best way to get started that you don't see the same results that some Europeans have with their trial casting at your facility, which the Asian companies succeed? What can you do as a foundry when you want to get started?
I mean, they can take help from people if the technical challenges is not really that difficult. I mean, Rheocasting, we talk about it as a new process and so on. I mean, Rheocasting, as we are selling it, it's a melt preparation before high pressure die casting. So it's not rocket science. It's not that new, so to say. But I think the biggest factor that people need to take into is that there has to be a business behind the trial. If there's no business behind the trial, then you don't really take it for real. There's very, very few foundries that has the ability to develop something and then take it to the market. I would say 9 out of 10 foundries need to have a business behind the trial, so to say. And I think this is why it have not started in a bigger scale than it has.
But I'm thinking about all the wasted money. I mean, if you look at the difference between buying a 9,000 ton or a 6,000 ton die-cast machine, what could the difference be? 10 million euros, roughly. Let's play around with that one. And then let's say in China you're producing 50 million cars and now you produce 16. It's not a massive jump upwards, okay? That's 1 million cars more, and they're pretty much based on gigacastings, all of them. That is, with the front, the battery, and the rear floor, 3 million parts. And if each of these machines are making 150,000 parts a year, which would be extremely good productivity for a 6,000 ton machine, first, then you actually need 3 million parts, 150,000. I get that to some 20 machines. And 20 times 10 million euros is 200 million euros, right? And do you think this sounds scary? Well, BYD, 4.6 million cars, increased the export to Europe with 91% first half year in 2025. It's not that super unlikely that they need another 1 million cars or will produce another million cars. So how long can you wait before really focusing on optimization of the productivity of gigacastings, if this is an opportunity, because you're investing and investing all the time. I mean, 26,000 ton machines, they are sizable. There's like small churches.
Let's see in a year or so what is happening. I mean, it's things is ongoing, so to say. So
so what you open up is a cliffhanger for another episode 1 year from now, when you can reveal who's actually using Rheocasting in volume production. We take that as a promise, Dr. Per, and thank you very much for being here in the podcast with us. And I think this is a perfect ending. And if you're listening and not subscribing, click the subscribe button. If you're more interested in more details, call Casting Campus, Fabian Niklas. He knows the stuff, the details, and can support you further to gain access to these markets that we have been discussing here. So again, thank you for listening.
Yeah, thank you very much.
See you in the next episode. Bye.